Yeah.
But
So other than that, I also wanted to just quickly run over what we're doing when we're engineering neural networks. So we talked about you had mentioned that there's some type of way that we need to decide how to call data, and if you want, I can sort of go over how that would work.
yeah, that'd be. I think that's a good place to take it.
Okay, so one of my favorite examples is like the novel example of handwritten digits and having machine learning algorithms figure out which digit you're writing. Essentially, what you're doing is just classifying things from 0 to 1, or 1 to 10, 0 to 9. So you got 10 digits, and basically the end product, the prediction that it makes, is going to be um, if if the number comes out less than 0.1, then it's a 0. If it comes out more than 0.1 but less than 0.2, then it's a 1. If it comes out, you know what I mean? So you stretch a number between 1 and 0, and whatever number falls closest to that category, you could say that the computer is picking which number it thinks it is. So that's how we're getting categorization out of numbers and matrices.
Right, and if it's not a whole number, you don't need to go down to the last decimal points to make the decision either.
Right, but usually you use a whole bunch of them just because you're only working with a 0 to 1 range. It's like called normalization. You take the biggest denominator and you divide
Right.
everything by the largest denominator. That way you can equally spread everything out in a really quick format. So one of the ways to do this is with an image is if you've got like a 1000 by 1000 pixel image, running a neural network through all 1000 pixels, and then as soon as you add a second layer to it, exponentiation kicks in and you're screwed within two activation functions or 2 or 3 layers. So usually what they do is they break things down into like I call it like a stencil. They call it a kernel, but it's easier to think of it like from an image as a stencil. And imagine your picture is this big. You go over a little square one at a time, and you run your neural network over one square over and over and over again. And in that square, all you have to do is multiply whatever's on the picture with what's in your square. And if you were looking for a vertical line, for instance, your little square would have zeros on the sides and then ones down the middle. So anything times 0 returns a 0. So if you put that block over the picture of your screen up here, it would return 0 down all the sides, 1 if the picture had a color or a light in it, and then 0 no matter what's in the picture down the other side. And that would be a vertical edge detection. Every time it crossed something that was dark and straight, those ones would multiply with the picture's pixel values. And then you've got basically a little frame or a stencil from the picture, and you can add them up, and then you remember which positions are where. Then all your algorithm has to tell you is there was one, there was one, there was one, there was one. So your next layer of a neural network will say, oh, every time I see one vertical block down here, one vertical block down here, and one vertical block up here, that's usually a street sign, for example. And that's where it's figuring out how to classify different images. It's by taking different shapes and structures from the stencils it draws of the images you feed it. And it's just looking for edges and boundaries and different shapes and blurs. And those are all just different numbers plugged into matrices. But it's not like it's thinking about what the essence of a car is. Like it doesn't look at a picture and say, oh, that can be driven. That can have a different interior. That can have a 6-cylinder engine. All it's doing is saying that the symmetry of a car from all these different angles, looking at these shapes and looking for these types of edges and boundaries, that's how it's going to classify whether it's a car, truck, or a boat.
Right.
You do that by feeding it.
So it seems like you could, with using probabilities also, you could get it to be like, okay, if you have a line here and it says, okay, this is a horizontal line. And then something like a stop sign is a horizontal line with an octagon on it. Generally, it has value of color coming out of it as well. So just stop sign. And then you could, okay, I'm back.
Yeah,
You could,
I heard you.
Sorry, no, I was waiting for my connection to come back. You could just tweak the probabilities so that it could recognize the stop sign from here, there, everywhere. Or you could just get people to identify it in that little CAPTCHA thing, prove that they were not a computer, and
That's
like prove
exactly
you're
what they use CAPTCHAs for.
yeah.
It was all training data. You ever come across a caption that asks you like 6 times?
Yeah.
They're just scalping data out of you.
Oh, I
They
know.
don't need any of that.
It's like,
but the neat thing is you can apply you don't have to go into it knowing what that stencil looks like. You can make the computer fill out stencils of random figures. Or you can do like in my project, I'm going to be using physics-based rendering engines, raycasting. And raycasting on GPUs is exactly the same tensor multiplications or tensor matrix multiplications that you're doing with sequential layers of a neural network. When we put the X on the top left of our tic-tac-toe thing, and it went from 9 available options down to 8, and we just multiplied and multiplied and multiplied down every successive dimension of the game that's possible. It's like doing that, except you don't have to predefine whether you're looking for horizontal or vertical lines. You could if you wanted to. That's how the early neural networks worked. But now we have such computing power with like 3D graphics engines and everything like that you can apply it to, you can basically apply it to like 50 dimensions at once, because you've got all your color values, your transparency values, refractive values. You've got like Fresnel lensing structures. You've got like Voronoi textures and Perlin noise. And there are so many different ways of manipulating a 2D surface to generate some type of image that could be applied as a stencil or a kernel to a neural network.
It seems like you could apply this to almost anything as long as you teach it the values.
Yeah.
The values being like it could be something even as weird as like which symphony brings more joy to people, and you show them like images of people liking them. It's like, okay, this one is happy, this one is sad, and you can even teach it stuff like that based on if you give it the right information. Or like my other thought is reconstructing or analyzing space data from like radio telescopes or something like that, where you get you get all this data coming through, and it looks through it going like blue star, red star, white star, what the heck is that? This is an anomaly, beep beep boop, and it sends the anomaly to the scientist who's like, oh wow, that's interesting. Or that's a pulsar, send it back.
So it can analyze 100,000 stars in a frame rather than looking at one star and hoping that one star does something interesting.
Right. So you can, and I wouldn't be surprised.
No, that's exactly right.
Yeah.
And this is my fascination with it. There's one layer even deeper than that, where you can feed it so many examples that it can generate things. It can generate human faces that have never existed.
Right.
Like it can generate terrain based on a handwritten drawing, or it can generate 3D models based on images that it sees from around the world. If you feed it enough 3D models that look similar and then render a 2D raster image of those 3D models, you can feed it a 2D model and then give it a 3D model, like feed it all the data it needs to have a 3D environment in a program like Blender or Maya or 3D Max.
Yeah,
and it can produce 3D models out of 2D images of places that don't exist and objects that were never built before.
That would be a fun thing to build fantasy worlds that you can go play in or something.
That's what they're doing with games right now. So like with these tensor cores that they put into RTX gaming GPUs, they're talking about ray tracing and shit like that. They're not going to use them for ray tracing because it's such a waste of processing power. They're going to do the same image map texture thing. If you look at it here, it's just a one reflection up of a blurry image. They'll use that and use all the tensor cores on AI because you can build terrains. Everybody could buy the game and all live in a different world in the game. And if you don't like the map, you could just restart.
Is that how they're procedurally generating those like infinite space types game where you can go to, or you can go into space and it's just
and they started doing that on
star systems.
Yeah, PS3 and PS4 were able to do that, but what they do is they'd have a procedurally generated universe, and then it would be fixed after they procedurally generated it. So that you wouldn't need to store all the data on the disk that you sell the game with. You just need to store the algorithm to produce that same map on every disk that gets installed. But with RTX cores and stuff, you could have it generate language and speech from non-playable characters, and they could develop a storyline as you're playing, and they could interact with each other through the town, and you can develop your own quests rather than having them pre-programmed. You could have your own battle systems. You can make up weapons and vehicles. Like, that's what they'll use the tensor cores for. They're not going to use them for ray tracing. That was just a gimmick to get people to spend the money so that they could develop the technology.
Oh, if it's in an ad, I just ignore it because it's probably a gimmick anyways.
Yeah, but it's all iterative steps. You have to go through the long, drawn out process of doing everything in small steps, because the power of AI that we can create more video cards at finer resolutions with more compute power at lower power, so that you can build better AIs that build more GPUs. Just like when we had computers that built CNC machines that built other computers, and all, UV spectroscopy and stuff like that.
This is pretty neat.
But yeah, that's what's fascinating. It's the generative potential of these neural networks that's really amazing, because that's when you're going to have computers say, is this a useful formula, to like an astrophysicist? Like, no. Is this a useful formula? No. Is this a useful formula? Like, oh my God, I've never seen that before. And it's like,
Computer's like, nice.
Yeah.
It doesn't even need a treat.
Yeah, exactly. So to me, that's where the biggest thing is, because once you can generate things like language, then you can put together worlds where policies and markets aren't manipulated. You could truly put things on an even playing field if there was an algorithm that was actually working to diversify the assets of the planet amongst people in a meritocratic way. It would be an impartial, unbiased way of going about it, rather than the system of nepotism where, like, your dad was prime minister, so you become prime minister.
Yeah, I don't like that.
Or like your dad was rich enough to run for government, so now you're president of the United States. Like, yeah, that's not a workable system in the long run. That's how Rome fell.
How people would be wary of that, and I'm even kind of like at it, because it's just like you see the echoes of everyone according to their wants, everyone according to their needs, or something, or everyone in their place according to their needs or something, or according to their abilities. I don't remember the exact quote, but the quote, and it doesn't work at all, because everyone's place ends up being 6 feet under. So
but it depends on how you implement it. If you implement it and follow it blindly, then you're just bound to have the thing crush you. Like, that will never work. You got to use it as a tool.
Well, you don't want to say motivated. You don't want the machine to end up saying, like, no, you can't have this because you don't deserve it. You want the computer to say, okay, people are looking for this. How can we give it to them in the most efficient and realistic manner? And then it'll, look for it. And then it won't be like, no, you don't deserve this.
Yeah, but you're looking at it like a gatekeeper again.
Exactly. And
by any means that we should do that. What we should do is have a system that says, hey, computer, I'm uneducated and poor. What's my best effort to get ahead? And that should just be available to everybody. Yeah. Everybody should have that same, because some people know that they can go to a library and get help from a librarian to study something. And other people just give up before they even start because they don't believe it's even possible for a black girl to become president.
Right.
You want an impartial system that says, no, that's false, patently false. No matter how good your parents are, I'm telling you, you could be anything.
Right. And then and the computer's, you're like, I want to be the president of the United States. And the computer's like,
yeah, here's poli-sci. Here's how you do it.
Here's poli-sci, but are you sure that's what you want? Are you sure? It's like, it's not a very good job. It sounds cool.
It all comes down to how it's used. And the thing is, most people are going to use it to try and get a leg up on their competitors. And that means like countries over other countries. And that's what causes conflict and wars and terrorism, is people trying to stand on top of other people rather than trying to get the most benefit out of synergies between people.
Right. So you end up, you want a system that'll reinforce the freedoms we have.
And that's notoriously difficult for our brains to fathom because of the complexity of society of today. But for a computer that can run through all these other algorithms, you just need a clever few engineers, or even a group or team of them at universities, to manipulate those stencils well enough that the computing power we have access to is able to process something useful.
So this sounds a lot like the our channel's namesake.
Yes.
So there's
Down to a point with no dimension.
So yeah, in the culture series, there's this culture in space, and they're just this stupid utopia where everyone just goes about and nobody understands what they do because they can just do whatever they want. But the whole society is just ruled by these computers that they just put in charge because they're smarter than us. And the computers themselves just go around in their freedom saying, well, this is kind of what I need to do to protect the lives and freedoms of the people in my society. So I'm just going to do that. And there's a dirty tricks division. But which, there's always, you can't have a story without conflict. Conflict usually comes from outside though. But these computers they're calculating and calculating and calculating, and sometimes they talk to each other and sometimes they play games. But
that to me is kind of like leaving your baby in the hands of your steak knife.
Right.
Like a steak knife is a good tool and it's genius in the way that it's been galvanized and everything, but it's not going to replace a human caring for a baby.
Right. But we can also consider a politician a tool. So
yeah. But again, you don't want to give politicians absolute power. That's why we have separation of state and executive and judiciary, right?
Well, that's also why we make politicians part of our society as equals. A politician is a citizen, and that's
supposed to be.
They're supposed to be, but they're still a tool. But
especially tools.
I keep thinking like the next election I should run for like a Green Party candidacy just for giggles and stuff, because like they'll just be like, no one wants it in this riding. Yeah, sure, we'll take you. And I'll just put my name in the docket, and I'll have let's have my face smiling there, like
zero marketing budget, just go door to door.
Like, yo, I'm the Green Party guy. You don't need to vote for me. I'm just here to shake your hand. Anyway, have a good day. Go to just chum with people. Probably get like 5 votes because hey, I remember that kid.
Yeah.
But I always thought that'd be fun. But like, I don't know. It's I think it's good that this is also a very slow process. So we're not going to come out with one of these in the next 3 weeks and go like, look, I can fix your system, beep boop, everyone must wear these hats, that's all you need to do. And everyone wears the hats, and it's just like, okay, ever since we started wearing fedoras everywhere, I don't know why, but society works. But if you take it off though, society falls apart.
The thing about it though is, even though it's going not like light speed, it's going slowly, it's already outpacing us. Like we already have hand dispenser sensors that don't read black people, so they're saying that because dark skin doesn't register as brightly on a image photovoltaic sensor as white skin.
Yeah, there was
the algorithm racist? Is the hand dispenser racist? Should it be banned? There are ethical questions and regulations to products like that we really need to talk about that we're not talking about.
I could do an entire episode on the idea of just banning stuff, especially when there's already laws, making stuff illegal. Yeah. It's like ban stuff. It's like, oh, okay. But I remember at the museum I worked for, we had this Kinect or Xbox Kinect thing. And so it was like one of those games where you move and you see yourself move on the screen, or your little thing, your avatar move. And it did have a lot of trouble seeing the black children because, their skin's darker just by dint of,
that's how quantum mechanics works.
So what happened was we have to keep the museum dim because light affects artifacts. So they'd be trying to play this game in like in the fun area, and the black children would be like, it's not working because it's already dim and they're dark. Mm-hmm. And then it's like, oh, and I can see how people would think that's racist, but it's just a contingency that the programmer who didn't take into account because, well, version 1.3, not version 10.7.
Yeah.
So it's a racist. Should we ban it? No, we should fix it.
Yeah. That's the thing. And they're trying to ban science over outcomes that didn't meet their expectations. And that to me is the same thing as the Catholic Church burning books because it didn't meet their idea of the universe.
Right. And even expectations now, not like theoretical expectations at this point. So this is kind of what we know now. Racist. It's like,
well, yeah, throw it out.
You let us finish.
Yeah. As if there's nothing more to be learned or gleaned from neural networks just because its soap dispenser didn't read hands properly the first iteration.
Yeah.
But like there are so many cases of this. Like you could have like machines that look at MRI images or CT scans and find tumors at a greater accuracy than human doctors do.
Yeah.
So spotting cancer early is hugely beneficial in treating cancer and people surviving it. So
Or if we
like even a 1% difference is hundreds of thousands of people who lived rather than died for like 10 years. So
yeah.
it's a big deal, but do you really want a computer running triage? Or like what training data do you give it? Because most black or brown skinned people that go to the hospital don't get treated for pain as often as or as easily and readily as white people. And
My
that's just
thought
a
is
fact of human bias.
my thought is you give people who are doing triage and are making the decisions, you give them a little, computer on their shoulder that's going to do the calculation with them.
With
And
them. Yeah.
and then after a while, it learns like it's like an internship. After a while, it's going to gather more data and say, okay, these people all in aggregate made decisions like this. So, and then from there, you can see how the action of triage, which is a very like there's some instant decisions made there that aren't made like you don't sit there with a chalkboard and go, who's gonna live and die. No, it has to be
A lengthy decision is worse than, or no decision is
to,
worse than a bad decision, basically.
yeah, it has to be like informed instinct. And so you can have it on their shoulder. But even then you can say, okay, and now we're going to go along in some low priority situations and give the machine priority over the person making it. And the person making it can be like, no, this. And then you can say after a while, version 20, then we can put them in there.
Yeah. And there's all kinds of ethical concerns like that we should be talking about. Like, if you wanted to apply machine learning to like reforestation programs to fight climate change, right?
Yeah.
It would be hugely beneficial to have a computer map out all this open space because altitude changes the amount of surface area there is on the ground. You can't just look at a flat map and say that's how many trees you need.
Right.
Based on the elevation of the hills and stuff, you can fit extra trees on them, or you need less of them, or
right.
Things like large scale world problems need this type of algorithm to fix it for them, because you can't hand write that type of artificial intelligence.
Because any grade 3 class can go into a random bit of land and start planting trees. That doesn't mean they're going to grow there.
Yeah, doing it efficiently and effectively also affects the planet, because you're burning carbon and shit just having people drive out there with seeds to plant everything, right?
Thank you for wasting those saplings. Also, thank you for using all that oil to get to there. And
and the tires, the rubber in the tires, and like the oil in the engines, and like there's all types of considerations. They're like airline routes, pathfinding.
Yeah.
Hugely difficult problem. You can use Dijkstra's algorithm on a quantum computer. You're still not going to get an efficient route making system for airlines to not burn jet fuel with empty planes. Mm-hmm. It just won't happen because people will cancel here and there, and that one person will be enough to flip the algorithm to change everybody's schedule. It's just not possible to keep up with a dynamic system.
Right. Well, air traffic control is notoriously a stressful job. Well, not just because of stakes involved, but because you're in a extremely dynamic situation. And you're taking in so many factors, moving, and you have to have so much focus. And it's kind of like if you lose your mojo, you lose your job. Mm-hmm. And so it's an interesting example. There's also a website out there that like tracks every single ship on the planet. You can go online and check it out. It's really cool.
Yeah, I've seen that.
Yeah, and it's like, imagine trying to be the guy at just one port, one major port,
Panama Canal,
or like Panama or Suez, just like blowing your mind. It's like,
yeah, the Strait of Hormuz. There's a whole bunch of them. And what's the other one? Kalamaka or something? And
is the Kiel Canal up in Denmark.
Oh, I don't know about that one. Yeah, I forgot.
Yeah. And
by Reykjavik.
No, that's in Iceland.
Yeah, but that's the path or whatever, isn't it? That's between the island
between
and
like Hamburg and like Copenhagen.
Rotterdam, Netherlands. That's
part
of that same. Yeah. Anyway.
Yeah, close to there.
Oh, weather patterns. How many like
Yeah.
captains of ships would love to be able to predict weather patterns better? Machine learning algorithms are much better at reading Doppler radar systems and slight changes in Navier-Stokes like field equations than people are.
Yeah.
And there are just so many examples, like the fake news stuff, criminal justice system, like the way laws are applied to people is, Black Lives Matter made it quite clear in all of their research and data that there is there is partiality in the justice system.
Well, like how like after lunch, you're probably going to get acquitted, but if it's right before lunch, you're going to get a terrible sentence. And lawyers will actually try to get
They'll game it, yeah.
They'll game it. It's like, okay, we got to get you in right after lunch. And it's like, oh no, he's blowing through them so he can go home early. It's like, oh no, and now he's going to give everyone's like guilty, get out of here. But at the same time, you see something like a sheriff in a small town, someone comes in for graffitiing, and he's just a dumb kid. I'm gonna make him clean it up and glare at him while he's doing it. Then I'm just gonna let him go.
I'll embarrass him in front of his friends, and that'll be enough.
Yeah, and that kind of creative justice, which doesn't work on a large scale, but sometimes you need to be, creatively lenient, and that's part of our justice system, is allowing for that sometimes. Like, I know it's like, well, boys will be boys, and well, the same applies for girls will be girls sometimes, because the judge is like, this isn't worth anybody's time. I'm throwing this out. Discipline your children. Next.
Yeah, and it doesn't help anyone in society to have people feel like they have no chance for the rest of their life at doing something. Like
Right.
demoralizing somebody for
Gram of
life for a
weed.
stupid decision they made as a child does not benefit society. It encourages criminality.
Yeah.
That's like statistically proven too. Like,
yeah. So yeah.
So there is the problem of the engineer of the neural network injecting this type of bias, because like you said before, with the hand soap or with facial recognition, it depends on the training data, and there is a human being curating training data. Now you could say, oh, well, you write a program that impartially curates but then
that's
that
also
program's
programmed.
written by a human, and yeah, it's the chicken and the egg thing basically. So the ethical problems we need to address, not because they're so severe right now, but because they're present right now. And I think conversations like we're having, and a lot of other people are having on YouTube and stuff, go a long way just to make it more like accessible, so that people can talk about it reasonably and rationalize about artificial intelligence without thinking that it's
the Cylons are coming.
Box of magic. Yeah.
Yeah.
They're coming out to get you, or that they're going to replace human beings with computers. It's just, we're just going to make computers do the hard work.
It's like, who knows, like you might have, and this is one thing, there was another science fiction author that I really liked. Well, I liked some of his work. But a lot of other of his work was kind of in a weird place. But he had this one book, and I don't expect anyone will read it. I don't even remember the name, but everyone had essentially their own AI, and it was kind of like in a chip in the back of their neck, and it would just talk to them. It'd be like, hey, I'm playing you some music because I think you need this, and you'd be able to talk to it, and it'd be like, they were asking like, how do you feel? And be like, I don't feel, I'm a program, geez. And it would tailor its personality to the person. It was just like your own personal assistant. And I thought this was genius. Like, what is AI going to be? Well, they're going to run our lives. It's like, why can't we all just have our own little paperwork monkey in our head? Yeah. And doing less stuff that we don't need to do, that is a waste of our time to do, and acts as kind of almost a companion to us. We can turn it off and on. It can guide us. It can help us reach our potential on an individual level. And I thought that was really neat, because it's like, it's in you and you don't have to have it on, but it's there. And it's like, I'm here to, help you run your life a bit better. And it's not a master, it's a secretary.
Yeah. It's like, it soothes people that are lonely, and it gives advice to people who are trying to strength train or do well for their health, or to help them study. And like, it's an enhancement.
There's one point in the book where she's just going on this long hike because, the plot happened, and she has to walk through for like kilometers and kilometers. And it's just like talking to her. It's like, do you want to like sing with me? And she's like, yeah, that sounds fun. And like, once she got like a little annoyed, it was like, all right, let's stop. And I was just like, that sounds like exactly what we should be doing with this. Creating these personalities to live with us, to enhance us, not to, lord over us, because we have that very governmental thought process that we tend to, like, well, if we get rid of our government, what kind of government are we going to have in place of it? And like the anarchists are like,
it might be like a residual like fear from feudalism. You know what I mean? Like that might be genetic programming too, to be afraid of our masters or something lording over us. That might even be a genetic.
You keep hearing like Jordan B. Peterson talk about how the alpha rats or chimps or something will always let the rest of them. You can't just like beat your chest over the rest, because everyone will gang up on you. And I think we're worried about that with computers, because they can do things better than we do. And if we're not careful, we could just, and we're stupid about it, we'll just make things that don't have anything to do with us. And I think if we do it carefully and we integrate them with a bit of wisdom and have these conversations like we're having right now, we can better integrate these into our lives and shed these structures, just like we shed feudalism, just like we shed colonialism. And we can shed the structures that frustrate us to no extent today. And
we can optimize the resources we already have, rather than trying to get more and more and more just to have excess, just in case we need them. You know what I mean?
Yeah. And like yes, if we could just optimize the everyone's like, oh, we could optimize the energy grid, or we could make more, or we could just have a more efficient technology. So do you want to have all the coal burning, or do you want to have a nuclear fusion technology that's safer, pollutes a minuscule amount, doesn't really kill anybody, and kills like a 5,000th of the amount of people? It's
well, with all reason, and
it's efficiency, essentially.
Yeah, even existing nuclear power, you could build successive nuclear reactors that you spent fuel as fuel for successive reactors. We could already do that.
Yeah,
we just don't, because we don't want to build 3 reactors because they're expensive, even though we know it's best for us in the long term.
Yeah, I'm reading Matt Ridley's new book on innovation, which does get into that to some extent. And he's kind of...
But it's like current technology. It's not like we have to develop something or learn it. We just have to build a plutonium reactor, a uranium reactor, and a thorium reactor. And then, you just wait till one decays into the other and you plug it in.
And he was saying essentially like thorium is probably the most useful thing we don't use.
Yeah.
He's just like, and he's this very calm guy when he writes, and you just got this feeling that he's just got this like indignation right behind his voice, but he's a professional. So he's just going to be like, thorium is probably the most, we have these safe things that we could use. Let's innovate. How does innovation work? And then that's what his book's about.
But it requires ourselves to have a long-term scope. And right now we struggle even to convince people of mask wearing during a pandemic. And we struggle to convince deniers of climate change for 30 years now. Yeah. Even when I was a kid in the 90s, you had Greenpeace out in dinghies bumping into oiling and whaler ships and stuff. And like, we knew about climate change for at least 30 years because I saw it 30 years ago.
Well, if you climate change is definitely a thing. Go to the Rockies and talk to the conservators and let them show you what's happening to the trees, and you'll definitely see that it's a thing.
And that's what I'm getting. We need like a long-term scope, and that's a philosophical, cultural issue that we need to deal with. That's not something we can fix with a tool. We need people to sit and actually think and talk about what's in their best interest as humans.
Yeah. As humans. Well, and I think this technology represents a hope, because I remember in university, a lot of people are like, we need to start a conversation, which is that's every time you hear it, it's a cop out.
Yeah.
We need to start a conversation.
Laziest way of starting
There's someone who doesn't know what the heck to do, and they're trying to get other people to do it for them. People working on this are trying to use a tool that will aid us in thinking about these things. They're actually thinking about it. And so we're having a conversation right now. Now what? We're having a conversation about what we can do, not having conversation come to a conclusion. We need to have another conversation. No, here's something you can use. It's right here.
It's like raising awareness for injustice and be like, oh, there's injustice, but you're just playing I Spy. There's injustice. There's injustice.
And then they
I'm
don't
not gonna
define
fix
justice. What is justice? Oh, I don't know. It's a word you can't define. It's like, well, you know it when you see it, so let's put some words together. We need to have a conversation. Okay, why aren't we? Obviously doesn't mean you, because then we could just do it right now. It's just one of my big pet peeves. It's like passing the buck.
And speaking from first experience, they don't want to listen either.
Yeah.
Oh, you don't know anything about artificial intelligence? Let me explain it to you. Nah, I know enough.
It's like, yeah, I'm good.
Yeah, I'm good. But anyway, if you're watching still after, I don't know how long we've been talking, but I'm gonna have to run right away.
Yeah, I think we had a good conclusion.
Any final thoughts, Jerry?
No, I think that's I think I had a few final thoughts there already. I'd like to actually probably make a shout out to we have a couple watchers, one of whom I used to go to the hub at U of M with. So hi to you. Yeah. Thanks for watching, Jason.
Mitaina.
Yeah. And as always, if you have anything to say, just any of our watchers, just let us know in the comments.
Check out the RSS feed if you want the audio only versions, but as always, we'll keep publishing to YouTube.
Yep. All right.
Thanks for the conversation. Ciao.